Good morning or good afternoon to all of you. My name is Kenrick. Today we are proud to actually have a speaker called Pavel. So Pavel, he works for FastNetMon. I'll give him a good introduction about him before we actually hand over to him. He works for FastNetMon. He started his career as a software engineer in domain name and hosting industry. Throughout his career, he worked very closely with network, and shortly network security became his passion. Pavel specialized in implementation and operation of different networks, telemetry protocols such as S-Flow, NetFlow, and IPFX. His all-time favorite protocol is BGP. So could you actually give us a virtual welcome to actually welcome Pavel? Thank you. Hand over to you, Pavel.
Hello, I'm Pavel Odintsov. I'm author of FastNetMon. FastNetMon is a tool for DDoS detection, and I will share more information about how you can actually use FastNetMon, what options FastNetMon offers for you during this presentation. All the time, I'm very open for any kind of feedback, questions, and you can find contacts on this slide. Or also, I will have final slide with all my contacts again. So feel free to share, feel free to talk if you have specific questions. I'm very open for having a great conversation about like network security in general or like DDoS attacks in particular. So let's start. All the time when we are talking about DDoS, we have some issues with classification. What kind of DDoS we are going to talk? Let's be clear. In this presentation, I'm going to talk about network DDoS attacks. But network DDoS attacks, it's quite broad term. It covers many types of attacks, plenty of them. And there are many ways to how you can actually classify DDoS attacks. But there is one problem. Many of them use actually some, I would say, marketing names, like what does it mean when somebody mentions like slow loris attack? And if you are not familiar, I mean, you are not in cybersecurity, it's not your day job, but mostly you work with networks. It doesn't say anything. You can try to explain what does it mean slow loris, like fancy animal, slow animal, but it doesn't explain what actually going on inside. That's the reason why I start my single presentation from classification, what we are going to talk about. And we are not going to use marketing names of attacks. Sometimes they can be invented by companies, they can be named after like service used against, like for implementing this DDoS attack vector. But we are going to talk about how actually network engineers can understand. Let's talk from OSI model. Let's start from looking on header format for obsolete, I hope, very obsolete protocol called IPv4. What we can find here? We can find here plenty of fields. And my question is, what field can be used for DDoS attack here? Do we have any constraints? Do we have any limitations? And unfortunately, almost every single field on this slide can be used as attack vector. I think of course we need to keep version stable because otherwise like transit routers will drop packet. Also, we need to maintain total length and checksum to be about to legit because otherwise attack again can be dropped, but not in all cases. And of course, we need to maintain destination address. So everything else, like protocol, time to leave, identification, different fragmentation flag, total length, it can be changed. And every single field can be used as attack vector. So it's one of the attack types we are going to talk about. It's level 3 attacks, when actually malicious side tries to change some fields and fill your network with, enormous capacity and, overload your routers, fill up your app links. What's next? Do we have what else? Like, let's talk about, modern days, because this stuff is about obsolete protocol. Everyone knows it's obsolete protocol, and I hope everyone did great effort to make this specific protocol obsolete. IPv6. Great effort was put to develop new version of IP protocol called IPv6. And you can see we have way less fields for bad guys, and of course not good guys, to mangle with. And so does it mean that, IPv6 came with, included DDoS protection? Because, great effort put in development of protocol, you may expect magic things. And there is a problem, unfortunately not. Having class fields doesn't mean that we cannot use them for generating malicious traffic. So what we can change here, again, we need to maintain version number, at least to look legit. Traffic class can be changed, flowable, anytime. Payload length, of course. Next header, again, can be changed to any value. Hop limit, aka well-known TTL field, also can be changed. Source address, fine, can be set to literally any value. And one of the things which must stay most of the time stable is destination address. Because, otherwise our attack will not reach destination. But, it's not correct in many cases because, attacker may have direct connectivity with you, like over internet exchange, over direct peering connection. And in this case, it's not, a requirement. And literally any field but version can be used for attacks. So again, even for IPv6, we're in quite bad position. Everything can be used for DDoS attack vector. Let's move a little bit up in OSI model. Let's talk about level 4. We covered level 3 that almost everything on level 3 can be used for DDoS attack vector, and that's type of attack we are going to talk about. Level 4 is also in scope of our conversation. And let's look on TCP header side. I'm not going to talk about UDP. I think it's kind of unfair because UDP is the main vector of most dangerous attack types nowadays. But UDP is simple, it's just source port, destination port, and that's literally everything we have. But let's look on TCP. Again, we have lots of fancy fields like sequence number, window size, checksum, data offset. Do you have any limitations about attacker side to mangle with every of those fields? No, every field again can be changed. And if you can try to think, if attack is coming over protocols like a mix of protocols L4 and IPv4 and IPv6, and then again randomized in some ways over protocols of over L4, that's type of attacks we are going to talk about. So, and of course, let's describe some of the well-known attacks because, from network perspective, there are no reason to explain attacks in some way because all the time you can say, this one is port randomization attack. This one is a protocol randomization attack. This one is a unicast flood coming from one address. This one is well-distributed flood, which is coming from many addresses. And there are lots of ways how you can actually explain. But from real-world scenarios, you may deal with those attacks. So one of the most popular, and I would say from network perspective, most dangerous, it's TCP flag attack. One of SYN attack, ACK flood. It's actually when attacker just uses fake source IP address and then tries to overload your application. Because problem with TCP SYN packets is they're quite complicated for network stacks of different operating systems to handle, because for handling the TCP stack itself, it's very complicated, and there are lots of different lookup tables, trees, lists to maintain to keep TCP session alive, and that's the main purpose of this kind of attack. So UDP floods, many of them just generate some random or semi-random payload and send it to attacker host in attempt to overload their channels or their software on their end. GRIA flood, again, nothing special, just protocol field set to GRIA protocol ID. And one of the most popular ones, of course, it's UDP amplification attacks. There are many vectors of UDP amplification attacks. Most of the, popular ones are DNS, SSDP, NTP, SNMP. But this list is very incomplete because what I would say is there are at least 100 different applications and protocols, which can be actually used in some ways to create amplification. It's quite sad because sometimes amplification is just side effect of normal operation of some software. That's why it's quite simple for attackers to generate enormous bandwidth. And when I say enormous, I'm talking about terabits of malicious traffic coming from like enormous number of different hosts across the planet, which is quite complicated to deal with. Again, fragmentation attacks. Fragmentation attacks is just umbrella term to cover many types of different ways how you actually can, attack network stack of operating system again. Because, fragmentation is quite complicated again to assemble packet, deliver it as multiple fragments. Every single operating system need to maintain lots of state. Like, do we have this fragment? Do we have this part of this session? Or many things. And also in many cases, routers are involved too. So you can try to attack routers itself, but it's most of the routers, of course, they will handle it very well, but not every single of them. And so that's why it's popular, because it just tries to find out like what kind of complexities we have in our network stack. Is it complicated to handle? And if it's really complicated to handle for endpoint, I mean in this term, like server, then it's perfect attack vector, because we can generate small number of packets, and then by using small number of packets, we can knock down target system, which is main point of DDoS attack, unfortunately. And many ways of spoofed attacks. Just change your source address, and here you go. And in many networks, changing source address of your packet is perfectly fine. And it's shame because there are many ways, and one of the most known organization pushing to make it like kind of legal, or at least filter it out. That's MANRS. If you didn't hear about, try to Google it. It's a great approach. Like, you need to filter out that every single packet which is actually leaving your network is coming from your IP address, and you are not allowing bad guys to use your network as spoofing, for spoofed attacks type, because they're quite complicated to find out like who actually is source. And here you go, FastNetMon. And in FastNetMon, before we start talking about FastNetMon, let's talk about WES. I like this terminology because, DDoS attack is it's something very unpredictable. Nobody will say for sure, like this September, we will have 100 DDoS attacks. Nobody knows for sure. I have been working this industry for 8 years. And, I would say after all that time, it's almost impossible to predict it. Like back in time, before pandemic started, it was great correlation, like summertime was quite quiet. And then in September, when everyone back to offices, it started like lots of new attack vectors because, everyone working and lots of like different projects starting at this time. And then here you go, you can expect attacks from your competitors, just angry people, or, somebody else. But pandemic changes everything. So I wouldn't say that we have any correlation for now. We had like plenty of attacks in summertime. We have quite quiet period in September. October is getting more active. But you can find out like this slide, this statistics provided by Dutch National Scribing Center. If you didn't hear about them, so let's check, because they're really great. They're a non-for-profit organization which actually provides DDoS scribing over cloud for your company. And one of the great things about them that, their pricing is not based on, bandwidth directly, or it's based actually on your company size, which makes it very affordable. So which actually means if you're a small business or medium-sized business, you will be charged very fairly. And you can, if in compare with many commercial DDoS scribing centers available on market, it will be way cheaper for you. So look at them. And you can see we have small decrease of attack size. But again, it's small change from 300 gigabits to almost 200 gigabits. Again, it's the sentence for almost every possible network. So, I would not say it's, I cannot say for sure, like you can see graphs going down, but it's still a problem. And unfortunately, we still have lots of problems with DDoS. And in terms of attack types, DNS amplification still most popular one. And we keep most of the types of attack coming from amplification, and so it's a thing where FastNetMon can help you, because it's our complete passion. Because what we do, FastNetMon was built to fight volumetric attacks, and you can see volumetric attacks still most dangerous, most popular ones, and so there is a great chance that FastNetMon can help your network and save your network for next DDoS, and save your sleep. What kind of features we can offer in FastNetMon? There are many of them. There are some things which are part of FastNetMon's DNA. And one of the first things, it's not asking you to change your network. It's quite common for many vendors to ask you, you did your network wrong. You need to change, you need to rebuild it from the beginning, by different routers, deploying different topology. No. We accept that we live in the real world where changing network topology, it's way more complex than changing government. And, we are not going to do it. So FastNetMon tries to adjust to any single possible topology. So we do our best to cover almost all possible and impossible scenarios. If we missed something, you can make contacts, you can complain, and we can try to find out how we can do it. And different thing, because FastNetMon was built quite a long time ago, it was 2013, and it wasn't, time when almost everyone from network security vendors offered boxes. I mean, physical boxes, hardware boxes. And right now I'm talking with you from London, and I suppose most of the people here from Asia Pacific region, and even shipping some fancy box from London to say Australia or New Zealand, it's quite challenging task, and just put away from export, import regulation, just to fry it server. It's quite complicated, and it may not arrive in pieces as you send it. It makes hassle. And what is the problem? Okay, of course you can order equipment, it can be delivered, but what is the problem with DDoS? DDoS is a thing you cannot predict. Weather, as I said, it's weather. It's something you have no control on it. Because all the time we have even in DDoS world, we have pandemics, like we haven't now, because sometimes some bad guys decide to attack specific type of companies in specific country. And in many cases, this area may be unfamiliar for people because, for example, you work in just random example, maybe pharmacology. You never had problems with DDoS. You had never had any angry guys attacking you. And then something changed. You never had DDoS before, and you having it now. Your network is down. Your customers are complaining, and your management is frustrated. Can you order equipment? No, you definitely not. What we offer in FastNetMon, we offer software-only solution, which can be installed in a matter of minutes, not hours, minutes. If you spend some time in to test it before it happened, before DDoS attack happens, you're in a great position. You may have some configuration, save it somewhere, and then you can deploy it literally in minutes, which is great. And one more thing from FastNetMon, it's about automation. There are no cases when FastNetMon will ask you to approve something. Okay, we found out that you're under attack. Confirm it, apply mitigation, accept. Please confirm it again. One final confirmation before we start mitigation. And what is the problem? Problem with DDoS attacks, they are deadly fast. I mean, DDoS attack can escalate from 2 megabits to 100 gigabits in matter of 10 minutes. It actually means if you start to do something manually, you fail it. That's a problem. And again, we try to do everything most automated way. Sometimes, of course, we ask for feedback, but not in hot pass. When you finish the installation of FastNetMon, when you set configuration, which actually matches your network setup, your baselines, it will work absolutely without any kind of supervision. And you can, keep sleeping, and next morning you can find, okay, we mitigated few attacks. It's great stuff to have. And all the time we, in compare with many software projects, we try to speak not, software language, because for software engineers, their language is some fancy API, JSON API, some sorry to say, XML API still exists, unfortunately. And so we talk in a language which is familiar for network engineers. We talk BGP, everything. One of the key points of FastNetMon's native BGP integration. And we can, because mostly BGP's protocol to express some actions and some changes network configuration, and to receive information from your network, we have different options to retrieve it, and we use most popular protocols like NetFlow, IPFix, SFlow. It's mostly every single key feature of FastNetMon. It's it's not only key features, it's about DNA of project. So what we follow fiercely, so we just try to accept that some networks built the way they built. We cannot change it. And we accept that real world has complexity of delivering stuff, physical stuff. And we do our best to avoid all hassle. So you can install FastNetMon very easy. Back in time when FastNetMon was started, we supported just one distribution. But again, the real world is different, and every single company has clear reasons why they use, for example, RHEL or Debian or Ubuntu or FreeBSD or VIOS, and we accept every single of them. So no limitations. We are not going to ask you to install some specific Linux distribution you never heard about. No. If you have any preferences, you can deploy it on literally any Linux distribution available on market. And also, we actually support FreeBSD if you prefer. In terms of vendors, you see many of them. We support many of them, and this slide just includes vendors we definitely know for sure that our customers use. But it's of course incomplete. It's very incomplete, I would say, because in FastNetMon we just follow best standards. We implement RFCs, as close as we can to standard. And if vendor implements NetFlow or IPFix protocol and of course BGP properly, and they have no tricks or issues in their implementation, FastNetMon will work with it. In some cases, of course, vendors do the tricks. And in this case, for example, we have quite a long list of vendors who actually do some weird things. And we also do our best to find out, because, when some popular vendor does something incorrect, it becomes kind of correct. Because in FastNetMon, we support few drafts about IPFix protocol. They never became standard, but almost everybody uses them, so they are standard. It doesn't mean that there are no, published RFC about it, but, it's accepted by everyone that, this thing happens, it works this way. And what we do, we just, adjust to what we have in place. And all the time, we try to work with new vendors, and we receive lots of feedback from our customers about does it work well? If it doesn't, what was root cause? And we do our best to polish our implementations of telemetry and BGP to be in line with modern features and new capabilities available are exposed by vendors. So see, there are no limitations about vendor using your network, and of course everyone I hope use at least 2 vendors in their network. But still, I believe that some companies still rely on some specific supplier. But PG changing all things, because it was started since the beginning as multi-vendor approach, which is quite great to see. FastNetMon users. It's one of the things I'm proud about. We have plenty of customers. everywhere. I'm sorry, not customers, I mean users. So if you cannot find some pin near your location, maybe it's time to try FastNetMon. Just add one more pin and say like, hey, we use it for this specific country. You can see lots of countries, lots of cases. And what we do in FastNetMon, we just try to find out like cover as much as possible cases, and means which different countries, different scenarios, different types of companies. And there is a great chance that it will work for you already. I mean, out of the box. This presentation was announced as lightning fast, and I will keep promise. And FastNetMon can detect attacks really fast. And we have some numbers, and still we have some limitation about telemetry protocols used to detect attack, and they can add some additional delay. But for mirror and S-flow, it's less than 5 seconds. In some cases, you can easily make it even faster. Actually, this one does default like recommended configured, but you can do it even fast. Like for mirror, you can detect in 1 second. For NetFlow IPFix, it's more tricky because 10-30 seconds. It's not FastNetMon's fault. There is a flow timeout in NetFlow protocol by design, and so if your router allows you to set 0 timeout, which is possible, for example, for Juniper boxes in inline monitoring mode, then you can get it in like same time as, for example, for S-flow, like few seconds. And here you go. And before actually attack started, escalated like from maybe like few hundred megabits, and your network can handle it, then to a few gigabits, and your network still can handle it. But before it escalates like to tens of gigabits or hundreds of gigabits, it stopped. Fine, that's main point of FastNetMon, and why we think that automation is a must. We support plenty of network telemetry protocols, and we are working. It's one of the most active directions of FastNetMon's development. We are adding new telemetry protocols, like different ways of encoding, different ways of encapsulation, and there is one quite tricky problem because NetFlow, it's trademark, originally owned by Cisco, and I suppose they still own it. It's not actually listed on their list of like Cisco's trademark on their official site, but still they own it. And many vendors, they don't want, to have some issues with trademarks. And that's why you can find NetFlow protocol under different names, like NetStream, JFlow, some fancy vendor name Flow. So don't be scared, it's still NetFlow. Inside it's NetFlow, nothing special. And if you can see your vendor offers like something magic, try sending it to FastNetMon. Maybe it's under the hood, it's NetFlow. It's very likely. And you can remember this list exactly. So this one, we just started this discussion from covering, like we are going to talk about L3 attacks and L4 attacks. And what we do in FastNetMon, we focus on both of them. And of course, FastNetMon has complete support of IPv6 protocol. So we can cover both of the cases and easily find out what is the host is a target of attack. Some fancy numbers, again, I'm quite proud about them. And in same time, those numbers can look like, not very impressive because those are confirmed numbers. Those are numbers received from our users who said, hi, I use FastNetMon and my network is 2.2 terabits. But FastNetMon has no telemetry at all, and we have no information that you use FastNetMon. We have no information about your bandwidth. Literally no ways for us to say for sure that we have customers with bandwidth like 1, 2, 3, 4, 5. We don't know. And only one way, if you have more impressive numbers, please share. I'll update this presentation. And because literally from FastNetMon's perspective, there are no limitations about S-flow and NetFlow. Because, okay, we mentioned 2.2 terabits, but FastNetMon can handle lots of traffic. And even if you face some scalability limitation in FastNetMon, there is a trick, available in both S-flow and NetFlow protocols, sampling. Because the only one way how you can actually overload FastNetMon is by like enormous number of telemetry packets hitting FastNetMon. And if you can increase sampling rate, for example, from 1,000 to 2,000, you can cut number of packets landing on FastNetMon by half, and then same capacity. So in a case of any issues, you can literally accomplish almost indefinite scalability of us, which is great. And if you want to keep your original sampling rate, you can install multiple FastNetMons and spread load in some ways, so it will work for you. What we can do when FastNetMon actually detects an attack, it can do some things. Again, we're talking about complete automation. We are not going to ask you to do something, but of course, in some cases, it may be a case because, you know, you can use FastNetMon callback script to send fax, or, you know, make some call via phone, many things, but still it's up to you. And the main things we do when we detect attack, we can create BGP announcers with specific community, with specific next hop, using specific NLRI, a specific family, and then your routers can apply different custom actions according to this specific concept. It may be black hole, it may be diversion, it may be some precise filtering, it may be offload to cloud scribing center. It's up to you, and we believe that BGP is extremely flexible product that can be used to cover most of the cases required for DDoS attack detection and network automation for all purposes in general. And also we support script callbacks. If you don't want to create BGP announce, and if you want to create alert in your own system, notify your customer, walk up your network operators, sorry about it, and then you can just write simple script, which is, I'll show it and slice later, and it's really simple. It's definitely rocket science, and if you even if you had no experience with all these scripts before, you can just find out something on the internet, because there are plenty of them on GitHub. Just, you know, fill FastNetMon, and you will find out like lots of different implementations and integrations, different like systems like PagerDuty, DSort, like Slack, just email alerts, many of them. FastNetMon can be installed very fast. There are no limitations about type of server you can use. Again, there are no limitations about Linux distribution. Literally any like decent server, if you have spare equipment, you know, staying and doing nothing, and you want to try FastNetMon, that's a great option. It can be run in container, it can be run in virtual machine, it may be private cloud, it may be private cloud. Both options, and FastNetMon will work fine in both of the cases. We have no specific requirement about hardware. It works literally on everything which can run Linux, and then it will run FastNetMon. It actually can be Raspberry Pi, because we're getting more and more customers who actually use Raspberry Pi and to run FastNetMon. It's not, you know, just hobby, because sometimes people actually face problems that they have no space in racks. Like everything is filled up to 100%, and then you need some like device to run the DDoS detection, and then you can use FastNetMon this way. And we have complete support for ARM platform, which works quite nice for our purposes. How actually FastNetMon works? FastNetMon is not black box. There are no magic inside of FastNetMon. FastNetMon is baseline or threshold-based detection tool, because it actually means that it maintains plenty of counters on basis of host for IPv4, which is /32, or host for IPv6, which is 128. You just count number of packets arriving for specific host, number of packets leaving from specific host, and plenty of them. We have great detailization about, like, we use different counters for different protocols, like different types of like units of traffic, because we maintain counters about number of packets, number of flows, number of bytes. And then FastNetMon every few seconds checks every single bandwidth for every single host, and then compares with threshold values specified by you in configuration. Like if UDP traffic more than one gigabit, then this one is attack. There are no additional logic which happens in FastNetMon. It just immediately fires alerts or creates BGP announce. Because unfortunately, in many, many cases, there are no way to say for sure this one is attack or this one is not. And even if it's not attack, even for example, if for a specific service, you have like 1G for customer, maybe broadband connection, and customer definitely has 1G. And even if you put like 5G of legitimate traffic to this specific connection, it may be legit traffic, but it will cause DDoS. It will cause service degradation for specific, because there are no ways how you can actually put 5G into 1G, and that's the reason why FastNetMon doesn't check what's happening inside. It just maintains like if this is an enormous amount of capacity, then it's definitely attack. And of course, it's up to you to decide what is the threshold, but many people are quite scared by like threshold, it's magic values. It's definitely not. And all the time you may know this value. For example, you have like 3 uplinks, and every single of them like have like capacity of 10G, and then it's very unlikely that you can handle more than 10G of traffic against specific host. Then it's your threshold. Or in some cases, for sure that none of your customers can generate more than like 100 megabits. Fine. Then set your threshold values to 200G or megabits. And then if some service actually exceeds them, then it's attack. Simple. You may find all available threshold types in FastNetMon community. Some of them are more efficient, some of them for one type of some of them more efficient for different types of attack. For example, packet second threshold more effective against TCP SYN flood attacks because they typically have a really great packet rate. But to defend amplification attacks, you need to care more about bandwidth. So your choice bit second. In case of spoofing attacks coming from many addresses, flow per second threshold may help you because it actually reflects number of hosts actually reaching your service. And it's way more simple to maintain because typically how people deploy FastNetMon, they just enable it in a non-active mode, with BGP unknowns is disabled, and then look what is their baseline traffic, what's their average traffic over week, and then they try to find out what's the best threshold for it. It's not actually required to set every single threshold here. Don't be scared. For the beginning, you can start from simplest one. It's bit second. Set it to some crazy value like 10G. Look, if it's crossed, fine. If it's not crossed, okay, then you may try to lower it to make FastNetMon less sensitive or more sensitive. But again, it's up to your network because there are plenty of networks who actually may have 400G interconnections and they don't care about DDoS at all. And for them, it's 100G is an attack? No. It's legit traffic. That's why we believe that threshold-based approach is quite efficient because all the time we need to understand what is the scale of network. Because for some networks, actually 10 megabits can be, disaster if it's VPN server in some in the middle of some maybe Atlantic Ocean, which extremely limited connectivity and deadly expensive bandwidth. So, and then you can set it 10 megabits if it's causes issues for you. FastNetMon is quite versatile and it's not limited by your specific network. It can work if you can deploy FastNetMon alone, and FastNetMon can automatically black hole your own host under attack. You may, if you already use some DDoS filtering equipment, okay, it's also option. You can use it with FastNetMon and use FastNetMon to divert traffic from normal paths to the farm of scribing boxes in your network. So we are not against using FastNetMon with any kind of thing because we position us as absolutely vendor neutral platform, and we have no limitation about that. And also you can easily use FastNetMon for diverting your traffic into cloud scribing centers, which is again, we have no constraint you can use any DDoS scribing center available on the market if they implement BGP protocol. If they cannot implement BGP protocol, then you may ask them to write script and then call it from FastNetMon. If they use custom way, how you can actually do the traffic from normal paths to, to cloud scribing center. One of the main cases for FastNetMon is black hole automation. There is a quite simple diagram what actually happens, because when you talk about DDoS attack mitigation, for some, because we are talking about it from perspective of network operator, data center, hosting provider, attack mitigation actually means that we need to save our network. But from perspective of service, it may be different. Why? Because for network provider, if you, for example, have like 10,000 of customers, and for some reasons, again, you receive enormous spike of bandwidth against one specific customer right now. It fills your uplinks. It's like causes degradation on your routers. What you need to do? You need to save your network. There are no ways how you can handle it right now. You run out of capacity. You run bandwidth. You run out of capacity on your routers. You cannot do anything. And every single customer from 10,000 is suffering. What you can do black hole for this specific host. And then you can save your network. And it's the main point when I say DDoS attack mitigation. It's mitigation from perspective of operator. From perspective of end customer, it may be downtime, but it's completely out of conversation in this specific case. But we are not going to say, for example, like just black hole specific and then there are no problems. No, there are plenty of ways how you can actually save them. But first thing, you need to save your network. It's the first and foremost, because we had quite large amount of DDoS attacks against financial institutions in like last year. And in their case, DDoS attack was just, cover for main data extortion. It was just, a side effect to disrupt every single person or company. Oh, look, we have DDoS. But then DDoS wasn't the case. It wasn't the main target of this attack. They tried to steal data. But everyone was busy in fighting DDoS. That's why what I'm talking about, we just need to stop problem right now. And then after like few minutes, we can find out how we can actually save this customer. We can move traffic to scribing farm, again, in same. We can move traffic to cloud service, which can actually do it. But it's everything of those happens after we saved network. And it's one of the points of FastNetMon. You need to stop attack automatic way, fast and efficient. And you can see on this slide, it's quite simple because when FastNetMon actually blocks specific one of your hosts in your network, everything else keeps going, and everything else keeps working without any kind of interruption, because it just handled problem and then in quiet environment dealing with one customer, not 10,000 calls. So they actually reduce severity of incident from something like P0, all that everyone is calling, to something like P2, degradation for one customer or for a few customers. And then we can deal with it in a way more quiet environment. And we will find like way more ways how we can do it, because, you don't need to maintain network stability, because network is still working. There are no degradation, like total degradation of service. And then we can deal with a specific customer and we can find out what's the best way. And next thing is a little bit more complicated. It's the cloud scribing diversion. And in this case, we are not blocking customer, which is great. In this case, we just, how FastNetMon actually works in this case. FastNetMon works on basis of /32 or 128. And because of how routing works, we cannot move specific /32 to different provider. That's a problem, but we can solve it. What FastNetMon can do, in addition, FastNetMon can announce network in which actually attacked host belongs. It may be /24 at least, and then instead of using black hole to block every single piece of information coming to or from specific address, we can move a network which includes attacked host to scribing center. And because of BGP is quite fast protocol, and we can do it in less than 1 minute. And then every single piece of traffic will move away from our normal network to scribing center, which is also great because we can do it because FastNetMon is very fast. BGP is not that fast, but it's still quite fast. And you can expect great propagation latency in this case. And there is a great chance that you will move specific affected prefix away from your network before attack reaches some dangerous capacity of hundreds of gigabits, which is again FastNetMon can help you with, because FastNetMon can do it really fast. It can do BGP analysis out of the box without any intermediate boxes, any approvals, nothing. So you just deploy FastNetMon and FastNetMon will move traffic away. Again, as in previous presentation, you will not deal with global outage of your service. You may experience some short-term disruption of service because it may be a really swift attack, like enormous capacity. It may reach your uplink. It may feel that for a short period of time. But then BGP announce about moving away affected prefix to scribing center will propagate, and then all traffic, normal traffic, will move away to scribing center, and then you will receive only clean traffic delivered to you over private PIN connection or GRE or different types of tunnels available on market and used by scribing centers. But from your side, it will be completely automated. There are no involvement of network engineer or anybody in this process. Still absolutely completely automated way. And then you can see when actually attack stops, and then you can move it away or you can keep it forever, because some services actually attack it all the time, and there is a small chunk of services which just constantly under attack. So it's not like thing which happens like once per week or once per month. Sometimes they're just constantly under DDoS attack, which is quite sad, but there is some markets where it's it's very normal. One of the side features of FastNetMon is metrics, because to check thresholds we need to maintain plenty of counters inside of FastNetMon, and at some point of time we just decided to export them to customers, because it's quite useful to know like what's your bandwidth for specific /24. What's your total amount of UDP traffic in your network? Because those graphs are quite important when you deal with DDoS attack, because at least you can find out quite easily, like, oh, I didn't expect so much UDP traffic in my network. Oh, is this network expected to have 100 megabits, but it's actually having like 10G, and then it doesn't look legit. And those graphs can be used in addition to your existing monitoring system. And of course, you have some monitoring system, but in case if you haven't, which it can be a great start, because sometimes we position FastNetMon not only as DDoS detection tool, but also as traffic visualization platform, traffic visibility platform, because you can see it can be used to provide some visibility which works on basis of prefixes. So you cannot get this kind of information from SNMP counters. SNMP counter can say on information on terms of ports or total capacity, but it's almost impossible to correlate like ports and prefixes, because they can be spread over multiple ports, and it's quite complicated. That's why CIDR-based approach based on networks and hosts, it's quite more convenient, because in case of DDoS, you do not receive DDoS against port. You receive DDoS against specific host. And you need to know what host is actually targeted. And also you can, even if you don't want to use FastNetMon in a completely automated way, you can look on graphs, look what happens, then you can find out what is a host causing this havoc, and then you can block them manually. One of the options. And this one is backed by Grafana, and data can be stored in Graphite or InfluxDB. Both of them are quite scalable and handle quite large networks without any issues. And every tool I'm talking about is open source. There are no requirement about buying some licenses, libraries, license fees, nothing. Just install them, enable export, and FastNetMon will export all information for you. All the time when actually FastNetMon receives attack, it creates it's just exposes counters about specific host on time of attack. So you can find some basic description of attack type, attacks target. In this case, it's 10, 10, 10, 2 to 1. And this information can be used to understand like what we can do next. Like you may apply your custom logic about, for example, if this attack is less than 1G, apply one action. And if it's more than 10G, different action. Actually, how in real world customers use FastNetMon, they don't use RTBH as is, and also they don't use scribing diversion as is. On my previous slide, they actually use mix of them, because, for example, when attack is around 1G, you still can try to do maybe a filtering using your own equipment, or like just using RTBH and black hole it. But if attacks is more 10G for specific host, then you definitely can use scribing center because you have no choice. And there's a mixed approach which is it's getting more popular because main point to keep traffic in your network as long as you can. But when you cannot, like all your network, like in case when every single upstream is filled by malicious traffic, and you cannot afford to do it, like to receive more traffic, then great point, trigger BGP announce and move traffic away to scribing centers. So that's why we position FastNetMon as more automation, but not DDoS detection, because it's just about traffic management. When we see that like specific host or specific network consumes more than X gigabits, then do some BGP action, and then routers will move it to different prefix or move it, like, for example, to different part of your network. It's up to you to decide. This one is an example script which can be called by FastNetMon when it actually detects attack. It's very simple. It can be implemented in literally any programming language. We just call it this list of arguments and some information passed to standard input of script. And then you can use Python, Ruby, Perl, Go, like Java, any kind of language to implement your callback script. And then you can run your custom actions. Of course, you can run custom actions when FastNetMon actually blocks host and when FastNetMon actually unblocks host. Because FastNetMon has logic to automatically unblock host, because it's also quite important, because it's not enough to block host. Otherwise, people start calling you like, why you did it? And there are no reasons actually to block hosts in your network constantly. Because even very dangerous attacks, which actually in scale of time, tens gigabits or 100 gigabits, they don't last forever. They last, hours, in worst possible case, days, but they stop, which is great. And if, for example, some specific service experience a flash attack, again, I'm talking marketing, sorry about the flash attacks. Actually, it's like very short attack, but very, which involves great bandwidth. It may be like 10G for like 50 seconds or few minutes. What you can do, FastNetMon can find out when attack actually stops and then immediately unblock it, because there are no reasons to keep host blocked when we have no attack. And so if you can do it faster than attacker side, if they do, like, for example, like few flash attacks over like few minutes over whole day, and we block every single, but in very short periods of time, like 2 minutes block, 2 minutes of downtime, in total we'll have like 10 minutes of downtime for service, which is way better than, constantly blocking service. In this case, I'm talking about because also number of routes, number of ACLs, if you decide to create ACLs from FastNetMon script, they limit routing capacity and they may cause degradation. So it's one of the main points that, like, if you need to filter something, just keep rule for filtering when you actually need it. You have attack, fine, you have a rule. Attack step, remove rule, because what is the point to keep it here? Because for some, like, especially for firewalls, it's absolutely right for firewall, because some complicated filtering rule may cause significant degradation for firewall itself. And we had plenty of cases when firewall itself caused a degradation, and removing firewall or removing some complicated rules from it solve the problem with DDoS itself completely, because routers, especially hardware one, they can have enormous capacity without any issues. And if you have enough capacity from your upstream, that's very likely that you don't need any kind of DDoS mitigation at all. But in some cases, if you use quite a long list of ACL rules, filtering rules, very complex inspection like levels above of L4, then you may cause problems even for small DDoS attacks. So be careful with it. Community, one of the greatest things about FastNetMon community, because why FastNetMon called FastNetMon community? Because we have great community behind it. Like in total, we have about 4,000 of people in total using also such systems for communicating. So if you prefer a specific one, just join, just share your story, because, and if you have any doubts, any questions, first thing, just drop message. There is a great chance that somebody else did integration with specific vendor. Somebody else has, experience in dealing with some specific ISP, or some specific like customer had like implemented like great new shiny feature just introduced by vendor name. And so share your stories, and if you're unhappy with FastNetMon in some ways, of course, say it, share it, and all the time. DDoS attacks are like weather. They can make surprises, like volcano eruption in the middle of nowhere, like what's happening actually in like Canary Islands right now. Unexpected. And if you can share more information, because DDoS detection market is quite closed, unfortunately. And if more people can share their stories, how they actually defended this specific attack, what kind of attack it was, and investigate more about like what is the internal traffic involved in this, how it actually started, because every single attack which arrives in our network has originating networks. And if we can stop every single attack which actually live in core network, then at some point of time we may handle, we may eliminate DDoS attacks itself. Of course, it will be great, but of course it's almost impossible because there are plenty of networks you can actually generate. But if we can just little bit reduce number of networks which can be used for, amplification attacks or, spoofing, it will be a great contribution, which actually may not eliminate DDoS attacks in general, but can make them less harm. Less, maybe instead of like 100G, it will be 40G. And again, it's way better. It's way better. Every single step against DDoS attacks brings us to a little bit better internet, a little bit more stable internet. And so, if you want to discuss it, if you have any questions about FastNetMon, feel free to reach using any of those contacts. I'm very open. I have plenty of spare time to talk about FastNetMon. So if you have specific questions, how you can actually install FastNetMon, deploy FastNetMon, I can share, I can help. And so thank you for listening for my presentation. And if you have any questions, I will be happy to answer.